Hello, students and YouTube learners. This is Dr. Satish Singhal, PhD, Professor Computer Science, El Camino College. And in this video, which is video number 8, but I'm going to label this differently. This is video on a design example, so its numbering will be different. We're going to have 4 videos on this design example. So what is this design example? We'll explain that in a minute. But the small title is data processing using nested loops, and this is a special type of design where we are reading an input file. Outer loop is a UF control loop and inner loop is a sentinel control loop. Both loops have been discussed separately in some reasonable depth, and last video we showed how tokens can be read for a student record and data processed for their grade. We're going to show some of those same PowerPoint to analyze this again. So first video is we're going to introduce the data processing problem, and we're going to fix input output variables and intermediate variable. We're going to do that mapping. Okay. So title of this project is processing multiple student records from an input file. So we described that in video 7 before. This document was sent to you. You can hopefully have read that, at least have a copy of that, electronic or paper copy with you when you watch this one. But this is described in test, but I'm just going to jump directly to this, and this is going to be seen again, that a student may have taken different number of tests, and the file records their first name and last name, and that is constant for all students. Everybody has a first and last name. What is not constant is that listing of their scores out of 100 in various tests. So somebody like philosophy may not have taken any test. How do we know that? The last minus value is the sentinel value for the test score. That means that's an impossible test score. And the reason that is being put here, that we will read the real test scores and we will design our loop in such a way that as soon as this impossible or sentinel value is read, the loop will exit. So the major change here compared to lab 4 is that in this record there is no fixed number of tokens. Some student might have taken 5 tests, philosophy took no test, somebody might have taken 3, other might have taken 4. So we need to design a loop in such a way that we get the average of tests taken for each student and then determine their grade. Okay, so you can read that, and what we need to do here is some of the goals. Purpose of this software is to first create a file reading sentinel loop. That's a processing detail. We can do that, although when we know how to do that, it's pretty easy to do the whole program. But it's not a bad idea to create a file reading sentinel loop that will process record of a single student. So what we can do is we can write a loop that'll read either, it'll work either for this single record, if file had only a single record, or this single record. And when we have designed and perfected that, we can wrap that inside a UF loop. Okay? But it is very important to understand the sentinel loop design. It is inflexible in the sense that it must have following 4 factors. And playing any games with those 4 factors is never allowed. A lot of new programmers love to play games with designs, and sometimes that's okay, but in case of sentinel loop, it's definitely not okay. We have tested that for 20 years now, two whole decades, that if these things are not present in a sentinel loop, it either sacrifices the efficiency of the loop, it slows down the program, it creates one problem or the other. So that's why these factors are inflexibly present. So factor number one is that prime read is done before the loop begins. Prime read reads the first data and initializes the loop condition. Okay, so loop condition is tested based on the prime read. So that's why prime read before the loop condition is tested is always done. That's why do while cannot be used in a sentinel loop. You can use for loop, but then you cannot make it count control. Prime sentinel loops are event control loops. They're event control. They can never be made count control. Okay. Prime read is done only once. Meaning of word prime is important here. Dictionary meaning is the powder or other material used to ignite a charge. Meaning here is to prime the sentinel loop, ignite the sentinel loop. Okay. And loop condition tests the value stored in the prime read, and then inside the loop it tests the update read with a value such that when either read contains a sentinel value, loop will exit. Okay. This condition must be designed carefully. You need to now recall the sentinel loop video we did some time ago. Number 4, the loop tasks. Loop tasks are data processing. Whatever we read, we need to process that data in some way, and we'll have a lot of details of that shortly. Finally, the update read. Update read is done inside the loop. Update read updates the value of the variable being tested in the loop condition. And if update read is the sentinel value, loop will exit. Otherwise, it'll keep going and keep processing the data. This is very important to understand. Sentinel loop is always a pretest loop. That's why do while cannot be sentinel. And if somebody tries to do that, that's not going to meet my software approval. There will be problems, and I'll point those out. Okay. And what is required is that there will be inner sentinel loop that should be nested to process multiple records inside an outer UF loop. So what happens is that once sentinel loop is demonstrated to work properly, we extend the program to read the file storing records of many students. And this extension is done by wrapping the selected portion of single record processing program inside the outer loop that will run until all records are read and processed. This technology is called sentinel loop technology. And program requires definitely output to file, uses selected file, but console we do that as well, just to make program development a little bit easier. And you could do several output format. One format is to display records of student without tables, but lab 5 requires display in form of a table. So you should revisit the technology of data display in tables that you used in lab 4. Okay, so first, little idea here that for each student we are going to sum up their test scores, and we are going to divide that by number of tests, making sure the result is a floating point number. Once we have that, we can assign a grade, and the grading criteria, most of you know that if average score is 90 or above, grade is A. We have given numerical value for the purpose of doing average grade calculation and all that. I will not go through some of the part of this document. You'll have to read that yourself, but I'll go through the main things. But these are the grade threshold. Greater than 90A, between 90 and 80 B and C, and so on. And these are some more goals of the program. Program also computes and displays the following things: total number of students in the file, number of students who took no test, inactive students, average student grade for all the students. Okay, so now this is a huge program, so we're going to do a lot of documentations. First, we're gonna tell you high level procedural approach. Okay, so we kind of get to know the details of the procedure. That's not really the algorithm. That's not even high level algorithm. It's just like we're seeing key points of this software. So those are that you need to get input file name from the user. File may have data in it or it might be empty. Actually, slight change. We're not testing for an empty file. So that part will not be done, although that could be easily added. And then if this file opens successfully, then we'll get the output file name from the user to write output to it. If output file, if not existing, will be created in C++. That's a standard thing in C++. If output file has a legal name, it will be created if it doesn't exist. And for testing purpose, we will not write to output file in append mode, but in real industrial software, one could write data to an output file in append mode so that previous data in the file will not be deleted. And then for each student in the record that I showed earlier, right here, these are the student records. For each student, we are going to do the followings. We'll sum all of their test scores. We'll count number of scores, number of tests. We'll get the real average of all scores. That would be a floating point average, not an int divided by another int. And then we'll round it up by a rounding procedure. And we have done that for the rounding to nearest penny. And in this case, we'll round to nearest integer. And then we assign a grade based on threshold values listed here. Based on that, we'll assign a grade. And then we'll print all the information: student's name, sum of all scores, number of tests taken, scores also in all tests, real average, rounded average, and semester grade to console as well as to an output file. And if somebody took no test, like philosophy I showed earlier, okay, didn't take any tests, the sentinel value, for them will print that you didn't take any test. Okay. And then in the whole program, I'm printing a lot of things, but we'll print number of students in the file, which is number of records. And also student various grade levels, how many got A, B, C, D, and F, and overall average GPA. And this part I'm not going to discuss in the video. You'll have to read the document and learn that from there. Okay. And finally, the program is going to close all open file and then end the program. So that was my introduction, and this is a big software project, so introduction is pretty long. And we'll keep using part of the introduction in the other parts. But first of all, let's do the input variable type mapping and their data type. And that will depend what are we getting from the data file. So we're getting data file's name, that's one input. And what we are reading from the file are all the inputs. Of course, this is input file. So we're getting their name, first name, last name, and the test scores, which could be just used in one data type. You don't need multiple data type for that. But so what user going to be inputting from the file from the keyboard, sorry, would be input file name, and that would be a string data type. And this would be stores full path to input file, and file path may have white spaces. We use getLine for that. I think I described that in video number 4. And then user will also input from the keyboard output file name, and that's a string also, and it has same characteristic as the input file name. Okay, but the inputted data is also done from the file, and as I showed you before, each student will have their first name and last name, and we just need one variable to read their score subsequently through a sentinel loop. So there are 3 input variables, first name and last name. They're both string type. First name is student's first name, that is first token in every record in the file. Last name is also string type, that's student's last name, that is the second token in every record file. And one score is integer. Now, this I have to emphasize. If your file shows whole numbers, 80, 90, 75, 63, there's no rationale for anybody to use double or floating point data type for that. Okay, what's the rationale? Double consumes twice the memory of int. You can't do that. There's no rationale. There's no real reason to do that. If anybody does that in the test or in the lab, points will be deducted. One of our purpose is to write memory efficient program. You can't use floating point data type for integers. That is as simple as that. That's not allowed. In good software, that's not allowed. Bad software, that's allowed, but not in the good one. So that's why for one score I have in data type, because file has whole numbers. If file didn't have whole numbers, then I could use something else. So this could be one of the student test score, or it could be sentinel value, which is a negative value read from the file. That's why we use int, because all the values are not necessarily positive. Okay, so now we want to discuss output variable mapping. Let's look at that. So what we are outputting is a lot of different things, and I'm going to discuss only some of them. We are outputting back first name and last name. Both are string type, and they are the same variable that we had the input. So when you take input into some certain memory location and you just output them, then input and output variable become the same thing. But we are outputting other things. We are outputting sum of all their scores, and since all the scores were int, their sum will also be int. That's the other mistake I have no idea why people make. They'll make it double type. Come on, how come sum of integer becomes double? What makes it double? It's not. That's totally wrong. Assuming a double data type for sum of integers, it's an efficiency bug in the software. You just can't do it. That's not allowed. So sum is sum of all the tests taken by the students. Num test is name given to number of tests taken by the students, and that again has to be integer type only, because the student may have taken 1, 2, or 3, or 4 tests. They are all integer type. Okay. But the mean of all the tests, that would be double type, because we want to tell them, we will of course round it off later, but we just want to tell them what their floating point mean or average is. And that would require the take two integer but get the ratio in the form of floating point. Rounded means that we will take the fractional point and update it by to next one if it's 0.5 or above, but drop it if it's less than 0.5. So meaning of something like this is that, let's say somebody got 70.5 or 70.6, we will consider that to be 71. We'll use the rounding algorithm for that. But if somebody got 70.4, then 0.4 will be dropped and we'll consider their score to be 70. Okay, and that's the meaning of rounded. And then of course we will find the grade. That's chart type. Criteria was discussed earlier. And also we'll find number of students in the file. Okay. I will discuss only up to here, but you should read the document where we are computing all these things too. Average student grade, number of students who took no test, number of students who took test, number of students who got A, B, C, D, and F. This is in the document, but I will not discuss that in the video. Please go ahead and read that. Okay, so there's one more thing, that some of the variables are acting as accumulators. Sum is accumulating sum of all the tests. Num tests is accumulating number of tests. There is a very important characteristic of these variables. Accumulators have to be initialized to some initial value just before the loop in which they start to do accumulation. We'll point out importance of that in algorithm again, but we start to hammer on that right now. Accumulators must be initialized to some value. In this case, we'll initialize them to 0 before the loop in which they actually do the accumulation. This is a very fundamental rule. If you think about it, you will become very clear why this rule is there. If you don't want to think about it, then remember the rule. Okay? As simple as that. Okay, there are a whole bunch of computational aid variables we're going to need. I'm only going to discuss those. These are neither inputted by the user nor outputted, but we need them to do computations. I'm not going to discuss all of them, but just the important ones. And those are ifstream object called in, and that's the one that's going to get bonded to the input file, and offstream object called out, that'll get bonded to the output file, and sum of all the grades with points assigned to each grade, and that will be int type. So we don't have very many computational aid variables in this case, but we'll use them. Okay, so that's all as far as the introduction is concerned, and mapping of input, output, and computational variable is concerned. So this is Dr. Singhal saying goodbye from video 1 of 4, introduction, input, output, and intermediate variable mapping. 4, design example 5, which is data processing using nested loop, reading from the file and outputting to the file. Second video in this series will be long one because we are doing a lot of analysis. So please read the document very carefully, and I'll make this document available also because this has more pictures and things. But I will see you in the second video shortly. Thank you.